All right, lesson 4-2, solving systems of linear equations by substitution. Today, we are going to learn about how we can use substitution to solve a system of linear equations. Now, first of all, I want to look at Desmos for this example, just so we can see how the graph and substitution compare to each other. And then I'm going to show you how to substitute to solve so that you can see how you can get exact answers as well. So I'm going to go ahead and share my Desmos screen. And I already typed the equations in there, y equals 6x plus 7 and 3x minus 8 equals 4. And when I see this graph, I see they intersect here at negative 1.3 repeated and negative 1. Okay, so I'm going to show you now how we can get that same answer by substituting. Now, substituting is exactly what it sounds like. You're going to take whatever y equals and plug it in to the other equation where y is. So when we do that, we can rewrite this second equation, but instead of y, we plug in 6x plus 7. So I substituted the 6x plus 7 in for the y because they are equal to each other. And then you just solve this equation. So you distribute the negative 8. I'm going to combine like terms and add the 56 to the other side. So you get negative 45x equals 60. And then divide by negative 45 to get x equals negative 4/3. Now, remember, our solution to a system of equations is always an ordered pair. So once we get the x value, we then have to plug it back into one of our equations to get out the y value. So I'm going to plug it in to this top equation because it's a little bit less simplifying that I'll have to do. So 6 times negative 4/3 is negative 8 plus 7. So y equals negative 1. So my ordered pair is negative 4/3, comma, negative 1, which is the same thing I got when I looked at Desmos, but Desmos gave it to me as a repeating decimal instead of a fraction. So let's try it again, but this time with a story problem. And the story problem, they give you the equations. So it says a vacation resort offers surfing lessons and parasailing. If a person takes surfing lessons and goes parasailing, she will pay a total of $175. On Friday, the resort collects a total of $3,101 for activities. How much does each activity cost? So they tell us that 16 people go parasailing and 20 people take surfing lessons. So we can use the equations x plus y equals 175, because if we have a person going surfing and parasailing, those two things added together is $175. And then if we have 20 people surfing and 16 people parasailing, that's a total of $3,101. Let X be the price of the surfing lesson per person and let Y be the price of this parasailing per person. So I wrote those two equations in my math journal as a system of equations. Now, the only thing that's different between this example and this example is that the first example was already isolated for Y and the second example is not. So we have to do that first. So I'm going to subtract X from both sides and get Y equals negative X plus 175. And you can do that in either way. If you wanted to solve for x and subtract y, you could totally do that. The steps are still the same, but you're just substituting for the opposite variable. And I'm going to write the steps over here off to the side so that you have all of them listed out also. So the first step is to isolate one equation for one variable. And again, when you do that, it doesn't matter which one, but choose the easiest equation and choose the easiest variable to isolate for. Then you're going to do the same thing when we substitute it up here. You're going to take whatever y was equal to, and you're going to substitute it in to that equation. So when I rewrite my second equation, I'm going to plug in negative x plus 175 for y. And I'm going to solve. So I'm going to solve for x. So I'm going to distribute 20x minus 16x plus 2800 equals 3101. And then I'm going to subtract the 2800 and combine my like terms. So I get 4x equals $301. Divide by 4. So x equals 75.25. Now I'm remembering that the x variable is the price of a surfing lesson. So I'm going to write that out. It's for surfing. Then we're going to take what we get for x, because remember our solution has to be an xy pair. We're going to plug it in to solve for y. So I'm going to plug it in for the first equation. 75.25 plus y equals 175. So I subtract that 75.25 from both sides, and I get y equals $99.75. I'm going to write for parasailing. Because on something like this, if I were to write this as an ordered pair, yes, that's how my answer is supposed to be written. But in the situation, that doesn't really make much sense, because unless the person knows what x and y stand for, then that's not much help. So after we solved for that variable, we plugged in to solve for the other variable. And then you're going to write your answer as an ordered pair. And you want to make sure when you get that ordered pair, you check your answer. And you can always do this by plugging your ordered pair into both of your equations to double check. So I'll do that now. 75.25 plus 99.75 is 175, and then 20 times 75.25 plus 16 times 99.75 is 3101. So I know that it works for both equations, so I know that my solution is correct. Now, just like yesterday when we did lesson 4.1 graphing, we have specials. And so I need to show you how to solve those specials with substitution. And I'm just going to write them both out right now. Now it's great because both of them are already isolated for y. So I can substitute that value in already. I don't have to manipulate one of the equations at all. So when I do that, I end up with 6x minus 2 times 3x plus 1 equals negative 2. And I distribute. So you get 6x minus 2 equals negative 2. And end with negative 2 equals negative 2. Now, this is similar to topic 1 where we learned about specials. If we get a true statement like this, negative 2 equals negative 2, this is infinitely many solutions. If I graphed this, you would see that these were the same line. Okay, then I'm going to plug it in here. 5x minus 5x minus 4 equals negative 4. Now, when you substitute, always remember to put that in parentheses because when there's a negative sign, you have to distribute the negative to both. So 5x minus 5x plus 4 equals negative 4. And I end up with positive 4 equals negative 4. So if this is a false statement, just like in topic 1, there is no solution to this system of equations. So this is the same line, and this is parallel lines. All right. And then I'm going to go ahead and share my slideshow again with that last example on it. And this one is another example. And we're just going to do it by solving with substitution, except this time we have to write the equation. So I want to make sure we have that. It says Nate starts a lawn mowing business. In his business, he has expenses and revenue. Revenue means amount of money that he is making so that he can have profit. Nate's expenses are the cost of the lawnmower and gas, and his revenue is $25 per line. Sorry, per lawn. At what point will Nate's revenue exceed his expenses? So we can write one equation based on his expenses and one equation based on his revenue. So the lawnmower costs $200. So that is his initial amount of money that he's spending. And then he has to pay $2 per lawn of gas, where his revenue is going to be represented by $25 per lawn, but he doesn't make any right off the bat. It's just that much per lawn. So our equations are going to be y equals 200 plus 2x. That's how much money he's spending. And then y equals 25x. And in this equation, when they're both set equal to y like this, we can just set the two equations equal to each other. So I end up with 200 plus 2x equals 25x. And I subtract 2x from both sides to get 200 equals 23x, and then divide by 23. So I get that x is equal to about 8.7. Now, we are talking about number of lawns that he mows. I can guarantee that if he only mows 7/10 of someone's lawn, he's not going to get paid. So we need to round this up. So we can say that he must mow 9 lawns before his revenue exceeds his cost. And we can plug that in to see how much he will make at 9 lawns. And we can double check that that's where they're, well, if we plug in 8.7, we'll know that those should be the exact same. But if we plug in 9, the revenue should be more than the cost. So he makes $225, and then he would have spent $218. So that is true. And we can say that we know that he needs to mow 9 lawns. So that is how we solve by substitution. There's one more method of solving systems of linear equations that we will learn next.